Alright guys, welcome to Grasshopper Week 3. We're gonna look at a little bit of fabrication related definitions and strategies today. So if you go to the Week 3 fabrication module and you click in here, you will find some of the basic materials we'll be working with here today. Now, first off, I'll say that you might want to check this and see eventually if for some reason some of the unrolling definitions that we use in here don't work, then you might actually have to install this Grasshopper Python component first, although it may be necessary, it may not be. So this is just in case. Alright. Now, one of the first things we're going to try to do is actually use a Python script that will help us generate ribs for laser cutting. But in order to do that, we have to set up or be able to create the ribs in the first place. So as a hypothetical, I'm going to, and this is just one of the files that is given here, the topo cutter file, although I'm just going to actually create a new object from scratch. And the example I like to use here is actually the Torus, which is here with the solids. And you can make whatever you want here, really. Just do something that's more sort of horizontal and flat, so it makes sense. But I'm just going to draw a torus here and use this to begin with. Actually make it a little bit fatter. So that, and then, okay, so there's a little bit more meat to the torus. Okay, now usually, you know, the Rhino sort of workflow for this would be to make a bounding box like that, and then run, let's say, the contour command for the torus, right, and then use, you know, one of these two directions, XY direction, distance between contours, let's do 10, right. This is just a representation, and then do it again. Let's do X-ray, but this time in the other direction. So let's contour this, right, base point. And just somewhere around here, but technically you should be using the bounding box as a guide, right? And do that, right? Move this out. So with these, then you would essentially have the outlines to start, you know, the ribs for laser cutting, for example. And by using the make planar surface command here, surface from planar surface, planar curves, you can essentially create the surfaces that make, let's say, a rib model like this. Obviously it should be denser, but this is to illustrate the point. Now the Python script that we'll use will actually cut or notch these for us, right? But we're going to try to make this process essentially in Grasshopper, okay? To kind of automate things a little bit. The other thing I'm going to do here is I'm actually going to stretch this torus so it's a little fat in one direction, so it's not a perfect circle, right? Okay, so the first thing you notice is that since this is basically a surface or a BRep, right, a boundary representation, to get it, link it into the Grasshopper file, we need to pop in a BRep. So this is a BRep container geometry. So grab that, put this in, and then right click, set one BRep, and click on the torus to link it in, right? At this point in the Rhino viewport, you can actually just hide it, right? And then you'll see the Grasshopper representation. It's not as smooth, but this is just so Grasshopper can draw a little bit more quicker, right? So don't worry about the jagged edges. Alright, so same thing as you saw earlier, because in the Rhino workflow we use the bounding box, And so the next thing for us to do is actually use the bounding box as well. So in the Grasshopper canvas, I'm just going to double click and type bound, and you get the bounding box here. Okay, so let's go into the first input, geometry to contain, bounding box orientation plane. Orientation plane should be XY, which is this XY. So we're not changing the orientation plane as well, and by default it's set to the world XY. So we just push that in, and this is what you get. So that's more or less the Grasshopper version of what we had earlier. Now we need to think about, okay, well, we want to do essentially a series of contours, which in Grasshopper can be done a couple different ways. There's two very obvious ones. I'll show you the first sort of dumber version, but maybe a little bit easier to kind of understand, and then I'll show you a different version later on. So first off, what we want to do is actually get the corners coordinates for the box, right? And here, this is a box, and that's the orientation plane. So what we want to do is actually, you can just type this in, right? So just type box and see. So you get a couple things like box corners, box mapping, box rectangle. These are all sort of different related things. But most of this is actually in, let's see, surface, primitives, box, 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 right? Now, if you're looking to, this is to create the box geometry, but if you're looking to analyze the box geometry, then in a lot of these panes, especially on the left, you'll see on the surface tab, the curve tab, the vector tab, well, not the vector tab, but the mesh, there's an analysis, and then there's a utility, and it's usually organized the same way. The analysis on the very left, utility is on the very right. So for the surface, on the left side, analysis, actually on the very top here, you'll see a couple of the box related properties, and this deconstructs, evaluate some properties, and usually when you're building a definition, what I do is I just pop them in and see what they give you. Okay, now this one is actually pretty easy because I can just use the box corners, right, and see what it gets. It tracks all 8 corners of the box, so 8 corners of the box, correct? And if you hover over the outputs, it will tell you which corner it is, corner in X minimum, Y minimum, Z minimum, which is this point here. And if you pull it in, it'll actually highlight the points, right, the 8 points. Another trick I use if you're trying to figure out more intuitively which one is which, you can pull in from the geometry tab a point object, a point container like this, and feed it in. And if you select it, then you'll actually see in the Rhino viewport it turned green, right? So you know that, okay, that first A point, XYZ minimum, is this one. B is that one, right? C is that one, and then D is probably that opposite corner, right? If you sort of turn around, right? So it's going around A, B, C, D, and then E, F is this one, G, H, right? In same order, so counterclockwise. Okay, so this is just to kind of help you visualize which point these correspond to. All right. Okay. Now, so we want to essentially be able to sort of slice this donut that way and that way. So in the X direction and the Y direction, and to intersect it, right? And before we kind of look at that, we can just sort of browse at some of the tools available. And these actually usually pop up under the intersect tab. And in the intersect tab, there's a couple of these sort of collision detection or intersection panels, right? And the one we're looking for here in particular is a BRep plane, because we're intersecting a BRep and a plane that we're going to create later on, right? So right here, BRep/plane. So this is otherwise known as a section, right? Solve intersection events for BRep and a plane. So if we look at this guy, look at his inputs, it looks for base BRep and a section plane. So base BRep goes into that, obviously, right? And then section plane, we'll have to make one, right? Now the planes fall under the vector category, or the vector tab, and then here is the section that's called planes. Now we can make our own planes, in X, Y, X, Z, what, blah, 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 or construct planes out of all these different inputs, right? So these are all your options. Now we're going to go with the obvious ones. In this case, so the horizontal XY, that's the XY plane, right? If we're cutting this direction, we're trying to make sections in this direction, that is actually what the YZ plane, right? And then cutting in that direction is the XZ plane. So not the XY, but the XZ and the YZ, these two, right? So these two, the XZ, the YZ, and obviously you can double click and just say XZ plane, and that's the first one that pops up, right? These are the two types of planes that we're going to use. You'll see as soon as I pop this in, it shows up at the origin point, right, at the 0, 0. This is the 0, 0 point, and it highlights to show you which one it is. Now, the inputs for this actually is the origin point, origin of the plane is set by default to 0, 0, 0, and we can change that, right? So we want to change the origin point to one of these corners. So, for example, if I'm looking for, let's say, the YZ plane, which I want to start here and then cut sections going that way, I want to take the YZ plane and change the origin point to, let's say, the A point. Alright, and then you'll see that it gets moved over here as a sort of beginning. At the same time, we can just actually, for now, let's just assume we're going to use the same origin point for the XZ planes, so it shows up there as well. Okay? Alright, so that's actually pretty straightforward. Then just to kind of clean things up. So the next thing we want to figure out is, well, I have these two planes. How do I offset them, right? Multiple times. So the first thing, let's find if there's an offset. There's an offset for this, for surfaces, for curves, and if you go up, you'll find actually a plane offset, which is perfect. That's what we have. So let's use the plane offset. Look, see what that gives you. A base plane and an offset distance. Okay. So if we plug in just as a test, right? Let's see. I'm going to zoom in a little here. And just as a test, let's plug in the YZ plane into here. And you see it automatically. The next here, when I highlight this, the next one, that's the offset, right? And that's driven by the 1. Now, I'll double click on anywhere on the canvas and do 2 slashes, which automatically makes a panel. And I'll type in a number, like 5. And that just is a shortcut to making a panel that has a value in it, right? Now plug in 5 into this offset distance, and that basically controls that offset, right? So if you'll see that if I change this number to, let's say, 10, say OK, then it goes, the offset goes further, right? That's sort of simple enough to understand. Now the problem is that's not what we want here, right? That's we want actually multiple of these planes, multiple offsets, right? Now just to kind of demonstrate how this works, I'm going to right click here and change this to, right click on the panel and change it to a multi-line data. So this will actually change it in a category of data that's multiple values instead of a single value. Double click on it, so let's say put 5, 10, 15, 20, 25, right? And then just click outside of it on the canvas anywhere else to finish it, okay? So what you see is that the component knows that you're asking it to do this multiple times, right? And so it does it automatically 1, 2, 3, 4, 5 times. The other thing to kind of note is that these wires here, and I'm going to pull in a tab just to kind of show you, when there are single lines like this, that means there's a single value. So this is just, you know, 1 point. When there are multiple lines like this, because this is a multiple value, it goes from this sort of single line display to this double line display. Alright, so this is just a Grasshopper's way of showing you, okay, this is multi-line or multi-value data. This is a single value data. Right, just that's a sort of something to keep track of. Alright, so this is sort of ideally what we want. However, we want to actually be able to tie these values to, let's say, the dimension of the box, right? Ideally, instead of having to say manually specify these intervals, you want to be able to say, well, measure this box however long it is, regardless of, you know, the change of size or whatever, and then divide it by something, right, to give me, let's say, equal subdivisions, right? So that's what we're going to be shooting for here. So first off, we need to find a way to measure between this point and this point. So let's see, length of a curve, blah blah blah. That's probably not what we're looking for. So sometimes you have to try. Distance. Okay, distance, the first one. Compute Euclidean distance between 2 point coordinates. Perfect, that's what we need. So remember, you can use this point to help you visualize. So that's that. We know that A is that corner, and then B, I think, is this corner, right? So it's showing up as green. Okay, so for the distance, we want to plug in A to A and then B to B. And that, if we bring in a panel to check the data, should give us a distance, right, which is this distance, around 70. All right? Okay. So that being done, we want to take the distance, which is this value, and divide it. Right? We can divide it by a number. It can be a fixed number or a sort of changing number if we use a slider, right? So double click and divide, and it's actually this one, but to find it you can go to the second math panel, operators, division, right? So division, this is simple enough. Give it the first number, which is this, and then give it a second number here. Now for the second number we're going to use a slider, and I'm just going to double click and type, let's say 1 smaller than let's say 20, and keep these integer numbers. And if you type it in this way, you'll see that the display pops up. It's a shortcut to create a number slider, an integer number slider that goes from 1 to 20. Okay, and let's put it as 10 for now. So we can plug this slider into the B, and you'll see it basically does the division for us, right? More makes it smaller, less makes it bigger. If it's only one division, then it's 71. Great. Okay, so this is the basic actually division logic that we want here, and that's basically, this is actually the intervals, right? However much this length is, right? These become the intervals. All right. However, we need to make it into a multi-line data like this, right? So you need, like, 7, 14, 21, blah blah blah, and find a way to do that. Okay. So the way to do that, we'll actually find it under the set sort of tab, and you'll actually be wanting to use this a fair bit. Under the sequence sort of section,
series, right? So this creates a series of numbers, and we can see, kind of look and see what it does first, really quickly. By default, right, if you don't change any of the settings, what it does is it creates a series of numbers that go from 0 to 9, a total of 10 numbers, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the first number you can change, which is 0. The second is step size, which is the interval, right? And that interval is actually this, our subdivision number here. Okay, and the last number is the number of values in the series, how many times you want it to duplicate this number. Okay, so first number in the series, 0 is fine. The second number here is this. Okay, oops, Control Z. Right, and then the last number, how many times you wanted to do this, is actually 10, which is coming from your number slider, right? Okay, so you have 0, blah, 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 blah. Okay. Depending on how you set this up, right, that's sort of the first one, this is the last one. You might actually want to put in the first number here as well, right? So both of those are put in there, so its first copy is actually offset by 7, 14, 21, blah, blah, and all the way down, right? So that's set. So that sets up the first little cluster. This is just so we know the output. I'll delete this. So for the planar offset component that we had earlier, this is what you give it, right? You're giving this sort of series of numbers which become the offset distances. So if you plug that in, then you'll see that essentially this is taking that length, right, that distance, dividing it by however many you're specifying it, feeding it as a sequence of numbers into the offset component to do it all at once. And so if I make it more, then you get more planes. If I could make it less, then you get less planes. Alright, simple enough. Okay, leave that at 10 for now. But essentially what I want to do is actually these guys, right, this whole cluster here, duplicate it and just use it for this as well, right? So Control C, I'm highlighting them like that, Control C, Control V, and that will make a copy of it. Okay, now be careful, like pull this to the side so you don't get mixed up. So the couple things we need to change here are obviously the inputs for this, right? So this originally was going to the plane that gets offset, so I have to replace the one that's here with the XZ. So I'm going to pull that into there. Okay. The second one we want to change is the measured distance, right? The distance you want to measure here is actually probably something like this to this. Okay. And we can use any of these. So that's A, B. Let's actually just measure B to C. Okay. So for the distance, replace the inputs. So B goes to A, and then C goes to B. And this should actually give you a different number, 68, 58, right? Which should be this dimension. Okay. Now you'll notice this actually flipping around because of the way the direction these planes are oriented. These plane objects, right? World XZ, worldwide XZ plane, they're oriented in a specific direction based off of your sort of center points, right? And the offset component will offset them in the base plane's z-axis, right? So the z-axis for this base plane is actually in this direction, right? So that's why it's offsetting in that direction. So we'll need to either flip it around, but the sort of actually the easiest way to solve this is actually just to move your origin point for this XZ plane that I have highlighted here to this corner, right? And so if I swap that to, I think it's A, B, C. So if I swap that to C, then everything just goes into line correctly, right? C is on that side. Okay, so it's just like in this case, these planes are starting here and getting copied that way. In the case of the XZ planes, they're just starting there and then get copied this way. Right? That's the only main difference here. Okay, so it's just a simpler fix for now. Okay, so that's done. And then I usually just sort of try to organize these in a way that I can sort of put them together, use these align sort of tools a little bit, and Control G, make them a group, and do the same here. So kind of put them in an organization that makes them somewhat readable or makes sense. Control G. Okay. So one of these guys is the XZ planes. XZ planes is, and I'm right-clicking on the group in order to be able to give it a tag, and then see these are the Y ribs. Plane offset. Right. These guys are the X ribs plane offset. Okay. And then actually I want the X's on top, the Y's on the bottom. Alright. Okay. Now these are all the planes that we want the this thing to evaluate, right? So very simply, and I'm actually just gonna do this twice, copy paste 2 of them, so I get 2 of these. They're all connected back to this original BRep, which is the Torus, and we're gonna feed our planes into both of them like that. Okay, now at this point you can actually select some of these and then start hiding them, right? So spacebar, and then disable preview, right? Or the shortcut for it really is just to kind of select some of this stuff is Control Q, right? Which makes them gray. If you see a component that's gray, that means their preview is hidden, and I don't need this anymore. And we don't need the bounding box to show up, actually. Okay. And if you want, you can hide the BRep as well, but you'll see that we're getting all these section curves now, right? These are the section curves that we really want. Okay. So the next step is actually we want to make planar surfaces out of these, right? And while I don't think there is the same sort of planar surface command, even if I found it, but it's actually this, boundary surface. It has a slightly different name. It's also under surface, freeform, boundary surfaces. Okay, pop that in, copy a second, oops, copy paste, Control C, Control V to get a second one, and what we want to do is just do that, and you'll see that automatically we're starting to get the surfaces that we want. Okay, hide these, Control Q. Can align this. Alright, so at this point I usually you can say, well, just bake these if you want. Sometimes what I do is to kind of make things consistent, or it just helps if you're going to be feeding multiple things into here. For some cases, is to kind of just make a separate BRep container, feed that in, hide this, and then make this a group. Control G, Control G. I'm double clicking on the group to kind of change the group type, right? And this is just a display thing. Sometimes it just helps to be able to categorize different sort of groups. And then this is the X ribs, and this is the Y ribs. Whoops. Okay. All right, and so if I'm you'll see that this is the ribs going in the X direction, these are the ribs going in the Y direction. Right? So the X ribs, I'm going to bake them and put them on layer 1. The Y ribs, I'm going to highlight this, bake them, and then put them on layer 2. Okay? And if you wanted to, you could, group them at the beginning, but for now, this is fine. So we're done with actually this sort of first definition. You can save it. I call it the rib maker. If you look at the file or the JPEG file I've provided to you, it's called the rib maker. You can call it whatever you want. Okay, and I'm actually just going to close this. Now note that closing this doesn't close Grasshopper; it just hides it. If I bring Grasshopper back up, it's actually running in the background, right? It hasn't disappeared. All the stuff is still there. Okay, so clicking on this close doesn't actually close Grasshopper. You have to type unload, Grasshopper unload plugin. That's what closes Grasshopper for good, and then you can load it back again, right? But if you need Grasshopper back, you can do that, or you can minimize it by clicking on the minimize. It'll go into the corner. Right? All right, but the rest of this is actually going to be within Rhino. So we have our surfaces, and as you saw, this is actually adaptable, right? So if you wanted to, you can kind of, within the Grasshopper, you can change how dense you want your ribs to be. I would kind of cap it at 2020 overall, right? If just sort of double this density. If you go a lot higher, then probably the model will get sort of heavy. Okay, but just sort of know, this is one of the things you can adjust. And obviously, if I change the torus geometry in any way, I can just sort of relink it back in and updates, etc., etc. Okay, all right. So the next part, the second part of this is actually creating automatically the notches that will allow you to notch ribs into each other, right? Now manually this is a very tedious thing because you have to draw a line, find its center point, offset it, relink and cut things out, right? So fortunately some smarter people than us, than I at least, have created this thing, which is called Cut My Ribs Python script. So this is a script from Rhino, and all you have to do is just save this script somewhere. So right click Save As, save link as, and save it to wherever you want to put it, right? I have it in one of my folders here. That's what it looks like. Okay, and you'll be able to run it from within Rhino. So if you go to Rhino Tools, under here you'll find two scripts: Rhino script, Python script, right? Rhino script, you'll find some Rhino scripts that are the older version. This is usually for Rhino 4 and before, right? This is the older Rhino script that is dependent on basically C#, Microsoft.NET. It's a different kind of language. Now the newer language is Python, which is a language that can be combined actually and even eventually used on the Mac side. And so that's why they're moving everything to Python script. So run, click on run, and I'll actually have it here as well. So cut my ribs, say open, and it'll pause for a second, but then it'll run. Okay, select ribs on the x-axis. So this will actually just act more or less as any other sort of command that you have, right, in Rhino. So I want to select all the ribs on the x-axis. To make this easier, I'm going to get into my layers, and the ones on the x-axis are the red ones, right? So I'll hide the purple, do that, and then enter. Select the ribs on the y-axis, so I'll hide the red and show the purple, do that, right click, or enter. And then this material thickness for X ribs, this will be completely dependent on, you know, what size your boards are, right? What thickness your chipboard or whatever board is, right? That's the thickness, material thickness. So just to kind of exaggerate it, I'll put in 1 for both. Obviously, you can see that you can actually put in 2 different thicknesses, but let's just make it uniform. And it'll pause for a little while, let it run, and there you go. So you'll see that this has automatically notched in the right location with the right sort of width and thickness to fit everything together, right? And essentially the X ribs are notched so the Y ribs fit downwards on top of them. Okay, so this is the waffle structure, and it's really simple, and you can apply it, this sort of this grasshopper script, to any surface that is closed. Okay, any sort of BRep, it has to be closed for it to be able to get correct sections everywhere. You just have to make sure that your sections aren't, your section curves aren't open. Otherwise, the sort of boundary surface component will fail. All right, so that's the first example, and I'll see you guys in the second. Alright guys, this is sort of an addendum to the first rib maker video, because I said I would show you guys like a second way of making this, a slightly simpler way. And the thing we're going to use for that is actually the contour component. So if I type contour, this is actually the one that we're going to use, the first one here. And there's actually kind of different ones. But the one we're going to use is this one, this sort of normal contour command. Now let's take a look at it first. BRep or mesh to contour, that makes sense. Second input is the contour start point, right? So where you start. Contour normal direction. Okay, so this is a little bit more different, where you're actually having to give it a direction, or a vector, if you will, right, to kind of determine the direction. Last one, distance. This we know. Okay. So what I'm going to do is actually just copy the first 3 components from earlier, from that previous one, because everything else up to here is more or less the same. So let me show this again, and you'll see that I'm going to disable these for now, or hide them for now, so they don't get in the way. So I have the box corners. For the contour, what you want is the BRep here, right? The second input is the start point, okay? So the first contour is the X direction contour, right? And so the start point for that guy is obviously this, which is the A point. And then normal direction. Right now, 0, 0, 1 means it's going upwards in the Z direction. We want it to go in that direction. So because this is a vector, right? It's an arrow, and you can actually see this here, that's a vector. So let's go to the vectors, vectors tab, and look at how do you create vectors. You can look at points, look at vectors, and unit vector, unit x, y, z, right? These are vectors in those sort of directions. And then you go down, oh, there's a vector 2 point. Create a vector between 2 points. Makes sense, right? So a start point or a base point and a tip point, right? That's the sort of vector direction. Do you want to unitize output? We don't. So for this, you want to put in A and B basically. So A here, B here, and this vector is what you feed into this N direction. Okay? And then for the distance right now, which is empty, right? The distance, it's the same sort of logic as the one we had earlier, right? So do that, more or less the same thing. So basically what you can do is just to say, take these guys, Control C, Control V, copy them down, and then just be careful for the inputs that you put in. So the same thing goes for here to here, and then this gives you the number right there. Okay. Now the main thing is that because we're giving it a vector that spans from one side to the other, it knows when to stop, right? It knows instead of having to do the series as compared to before, you just tell it, you know, how many times or what the sort of interval is, right? It automatically does know where to stop, and that's the big difference here. So in this case, then things kind of get simplified to this much. To get to the contour, then you just copy basically this stuff down here, do that, BRep, can align these or clean these up if you want to, and that's it for 1/2 of it, right? So streamlines things a little bit. That's your these are what? These are the X ribs. X ribs contour. Okay. So if I hide these, show that, you know, you're basically getting the same thing. Okay. So then I can take all these guys, Control C, Control V, do another copy, but this time we're going to change these to Y. Okay, and then obviously because of that, you want to measure from corner point, different corner points, right? So A, B, C. So this time we want to measure from B to C, right? That's going this direction, in the Y direction. So the distance measure goes from B to C, right? And then your vector measure goes from B to C as well. And then if you've done it right, then this is what you get. Simple enough. So this is just a sort of different way of doing this, and you'll find that this happens a lot. You know, there's always sort of different ways of doing this, but I just want to kind of show you guys a slightly different logic. All right, so that's that. This is Rib Maker version 2.